With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with the question which says there are 2 point charges 2 microcoulomb and minus 2 microcoulomb are placed at point P and A and B as shown in the figure. We need to find out electric field intensity at A and D. So before starting, let's check the formula for electric field intensity, which is given by E bar, and it is nothing but it is given by the formula KQ by R square. Alright, so this is what the magnitude of the electric field intensity formula is. So using this formula we will try to calculate the value of electric field intensity at C and D. So let's take for the first part of the question at C. So first let's try to take point C into consideration. Point C is over here, and we know due to positive charge electric field intensity is away, and due to negative charge it is towards. And as we can see, B is near point to C and A is far point to C. We can say electric field intensity due to B will be more. Alright, or we can just make the direction over here. So this can be written as this will be electric field intensity due to B. Alright, and electric field intensity due to A will be towards right. Alright, and we are making it small. As we can see, the electric field intensity is less due to A as the distance is more. We can see distance is inversely proportional with the intensity. So here will be EA. Let's put a bar over it. Alright, so we can say net electric field at C would be nothing but it is vectorially we can add it E bar plus A bar. Alright, so now if we substitute the values over here, so we can write EB is in the negative x-axis and EA is towards positive x-axis. So we can write for EB, we can write charge is minus 2 coulomb. So just we have to take the magnitude of it. So K into 2 KQ by R square. If we carefully analyze the distance between B and C point is of root 2 only. So root 2 square, and the direction is minus of I cap, and here it would be EA bar will be again 2K dividing it by distance between A and C is root 2 and root 2 3 root 2 square into positive x-axis direction, that is I cap. So from here we can take the value of 2K by 2 can be taken out as common. So we are left with here it would be nothing but 1 minus 1 and plus of this can be written as 2K by 2 is gone out, so we are left with 1 by 9, and this is I cap over here. So if we solve this value further, we can get the answer as 2 will also get cancelled out. K into this can be written as minus of 8 by 9 I cap. Alright, or we can say this way 8K by 9 and minus of I cap. That is the direction of electric field on C due to A and B is towards left. Alright, so we can this simply it is simply indicating the direction of electric field. So this is the first part of the question. Now let's move on to the second part, in which we have to find the electric field intensity at D. So we can say at D we can write electric field intensity due to B will be in this direction. Since B is negatively charged, B is having a negative charge particle over it, so field line will be this way, so we can draw it over here, EB bar. Alright, and due to A it is in this direction, that is away, so EA bar. So its resultant will be somewhere in between. Alright, so we have to calculate the resultant of that, so we can write. So what we can do over here is let's write it more clearly over here. So this is our EA bar and this is our EB bar direction, and this is the resultant. So we can say if we join the lines over here, alright, So from here, the diagram, we can first have to calculate the distance between, that is AD and DB, distance of AD and DB. We can say, just we can apply the distance formula between AD and DB. So, or we can just use the Pythagoras theorem. This distance has been given to be as root 2, and this vertical distance is also root 2. Here it is also root 2. So we can say root 2 square plus root 2 square, that is 2 plus 2, 4 and 2. So this comes out to be 2, and this distance also comes out to be 2 meters. So let's write this as more clearly so that, okay. So now as we can see, this is root 2, this is root 2, so this angle will be our 45 degree, and if this is 45, so this angle will be 45 degree. So if we resolve the component of EA bar, so we can get this here along this component, we will get the answer as EA cos 45, and also along this we will be getting the component of EB as EB cos 45. Alright, and as we can see, both the charges are of same magnitude and both are at same distance, so both electric field intensity will be the same. So we can write for the second part of the question, we can say, as distance of point D is same from A and B, also charges at A and B are of same magnitude, so we can say electric field due to A will be equals to electric field due to B. So we can write the net electric field at D will be nothing but, if we carefully analyze, it is EA cos 45 in this direction, that is positive x-axis, and also EB cos 45, and we know EA and EB are same, therefore we can write it as 2 EA cos 45 or 2 EB cos 45. Alright, as we can see, its vertical component will get cancelled out, so here it would be, along this direction we will be getting EA sin 45, and along this we will be getting EB sin 45, both will get cancelled out. So from here this will be the case over here, and here we can multiply it with the I cap over here. So we can write 2 into EA can be written as K. Q is been given as charge on A is 2 microcoulomb, that is 2 into 10 raised to minus 6 coulomb, into cos 45 is 1 by root 2 into I cap, and dividing it by R square, that is 2 square. Alright, so from here we can say the value, all values will get cancelled out. The value of K is substituted as 9 into 10 raised to 9 into, here it will be 10 raised to minus 6, and what we are left with in denominator is root 2 and into I cap. So from here we can say the final answer or electric field intensity at D will be 9000 by root 2 into I cap. So this is what the exact value of electric field intensity at D we are getting. In the similar way, we can also calculate the same for electric field at C, and we know the unit for the same is Newton per coulomb, that is electric field intensity unit. So same we can do it for C also. We haven't calculated the exact value over here. So now we can say this is the second part of the question. So for first part we can write EC bar is given by 8K by 9 into minus of I cap. So just we have to substitute the value. So 8 into 10 raised to minus 6. So we have to convert the value of charge into from microcoulomb into coulomb. So we have to multiply it with 10 raised to minus 6, and the value of K is nothing but 9 into 10 raised to 9, and dividing it by 9. So from here the answer final comes out to be 8000, and here it would be minus I cap, and unit is again Newton per coulomb. So this is the answer to the first part of the question. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.